Imagine the moment when humanity first realizes our world is just a tiny part of an unimaginably vast universe. All the knowledge and perceptions about space that once seemed unchangeable suddenly crumble like a house of cards, opening up an abyss of unexplored possibilities. Each new discovery, like a drop in the ocean, raises more questions, leaving us with the feeling that we stand on the threshold of the greatest mysteries. With every step in space exploration, we encounter the fact that our understanding of the world is far from complete. The principles we use to explain cosmic phenomena become outdated, and new horizons, like mysterious stars in the night sky, beckon us toward uncharted distances. Behind each new discovery are people who, like ancient explorers, seek to unravel the mysteries of the universe. Not long ago, these questions seemed incredible. However, progress in astronomy and cosmology now gives us a chance to understand the most mysterious and unimaginable aspects of existence. In this journey, full of unexpected turns, we, alongside scientists, open new chapters in the history of humanity. If you're interested in this thrilling path of discoveries and want to stay updated on the most relevant events in science, don't forget to like and subscribe to the channel. That way you won't miss any important milestones in the world of cosmology. A century ago, Edwin Hubble made one of the most significant discoveries in the history of astronomy, fundamentally altering our understanding of the universe. He studied the Andromeda Nebula and discovered the variable star V1, which became a key to understanding the size and structure of the cosmos. At that time, astronomers believed that the Milky Way was the only galaxy in the universe, and all so-called spiral nebulae were part of our galaxy. This view persisted for decades and was considered an established scientific truth. However, Hubble's work with variable stars, such as V1, forced the scientific community to reconsider this perspective. Hubble employed a method based on observing Cepheid variable stars, which have a unique characteristic. Their pulsation period is closely related to their intrinsic brightness. This fact allowed astronomers to accurately measure the distances to stars and galaxies. By comparing the observed brightness to the known absolute magnitude, Hubble could precisely calculate how far these objects were from Earth. Studying the variable star V1, Hubble came to the astonishing conclusion that the Andromeda Galaxy, which contained this star, was located over 2 million light-years away from us, completely disproving the existing theory. This discovery marked a turning point in astronomy. It not only demonstrated that galaxies could exist beyond the Milky Way, but it also confirmed that the universe was far larger than scientists had previously imagined. Spiral nebulae, such as Andromeda, were no longer viewed as clouds of gas within our galaxy. They turned out to be separate, independent galaxies, each with its own structure and characteristics. Along with this discovery, Hubble also formulated his famous law, later known as Hubble's law. This law states that the velocity at which galaxies recede is proportional to their distance from Earth. This implied that the universe was not static, as previously believed, but expanding. This conclusion became the foundation for further research and led to the development of the Big Bang theory. According to this theory, the universe began about 13.8 billion years ago as a result of a catastrophic event and has been expanding ever since. Today, a century later, scientists continue to explore the universe using modern astronomical tools, such as the Hubble Space Telescope, named after the great astronomer. Launched on April 24, 1990, this telescope has significantly advanced our understanding of space. One of its achievements was measuring the age of the universe, which is 13.8 billion years, as well as observing distant galaxies and deepening our knowledge of mysterious objects like dark energy and dark matter. Thanks to the Hubble Space Telescope, astronomers have been able to study structures located at vast distances from Earth, as well as analyze the chemical composition and evolution of distant stars and galaxies. Despite being just a single point of light in the night sky, the variable star V1 played a huge role in the development of astronomical science. In celebration of the century since its discovery, NASA and the American Association of Variable Star Observers, AVASO, conducted follow-up observations of this star to study its behavior in detail. These observations led to the creation of a light curve for star V1, showing its regular brightness variations. Modern astronomy continues to rely on Hubble's discovery as a starting point for further research. With the aid of more powerful instruments, such as the James Webb Space Telescope and the Roman Telescope, scientists are exploring the farthest corners of the universe, trying to understand how it has evolved since the Big Bang. How did Hubble's discovery of the accelerating expansion of the universe lead to a re-evaluation of Einstein's ideas about the cosmological constant? In cosmology, the cosmological constant, denoted by the Greek capital letter lambda, also known as Einstein's cosmological constant, is a coefficient that Albert Einstein first added to his field equations of general relativity. He later removed it, but much later it was revived to describe the energy density of space, or vacuum energy, which arises within the framework of quantum mechanics. This phenomenon is closely related to the concept of dark energy. Einstein introduced the cosmological constant in 1917 to balance the effects of gravity and achieve a static universe, which was then considered the correct model. However, after Edwin Hubble confirmed that the universe is expanding, Einstein abandoned this idea. From the 1930s until the late 1990s, most physicists considered it correct to set the cosmological constant equal to 0. However, the situation changed in 1998 when it was discovered that the expansion of the universe is accelerating, suggesting that the cosmological constant could have a positive value. What scientific mysteries could be uncovered through new missions that extend the lifespan of the Hubble telescope? How would our understanding of the universe change if Hubble were to continue operating in space for decades? The Hubble Space Telescope was conceived as a crucial tool for astronomical research, but its journey to space was fraught with numerous challenges. Originally, the launch was scheduled for 1983, but technical difficulties delayed it several times. In 1986, the launch was rescheduled for September, but the Challenger shuttle disaster on January 28, 1986, grounded space shuttle flights for several years. On that day, during the STS-51L mission launch, the shuttle broke apart 73 seconds after takeoff due to an explosion of the external fuel tank, resulting in the deaths of all 7 crew members. The disaster occurred at 11:39 EST, 16:39 UTC, over the Atlantic Ocean, near the Florida coast. As a result, Hubble spent 3 years in storage, waiting for flight operations to resume, and was finally launched into space in April 1990. Upon reaching orbit, it became clear that the telescope had a flaw in its mirror, severely degrading the quality of its images. This threatened the success of its scientific mission and damaged NASA's reputation. Since Hubble's design included the possibility of repairs in space, NASA decided to send a repair mission to the telescope. In December 1993, astronauts conducted 5 spacewalks, installing a correctional device that compensated for the mirror defect. From that point, Hubble began to produce images that revolutionized astronomy. Hubble became one of the most productive scientific instruments in history. It led to numerous important discoveries, including the calculation of the age of the universe, confirmation of the existence of black holes at the centers of most galaxies, the discovery of ancient galaxies existing just a few 100 million years after the Big Bang, and many more. The data collected by Hubble not only solved long-standing scientific mysteries, but also raised new questions, prompting the development of new theories. Since its launch, Hubble has been a primary tool in laying the foundations of modern cosmology. By 2023, the telescope had gathered data that contributed to over 21,000 scientific papers, a number that continues to grow. Hubble maintains its lead in the number of publications, confirming its status as the world's most productive telescope. When shuttle operations were discontinued in 2011, plans to return the telescope to Earth for display in a museum became impossible. However, NASA hopes that Hubble will continue operating until at least 2030, despite its declining orbit. Future missions may help extend the telescope's lifespan, or even return it to Earth with the help of the private sector, though these initiatives have not yet been officially approved. Despite its age and challenges, Hubble remains an essential and irreplaceable tool for space exploration, and its legacy is far from over. What discoveries in the fields of dark matter and dark energy could change our understanding of the laws of the cosmos and its evolution? Are there particles that might explain their nature, and what could the discovery of these particles mean for science? Modern cosmology is undergoing a true revolution as scientists delve deeper into the study of two of the most mysterious and possibly the most significant elements of the universe: dark matter and dark energy. These invisible components make up about 95% of the mass and energy of the universe, yet their nature remains unknown. Discoveries in this field could be the key to unlocking many of the cosmos's secrets and significantly altering our understanding of the fundamental laws of the universe. Dark matter is a hypothetical substance that neither emits, absorbs, nor reflects light, making it invisible to existing observational tools. However, its presence can be detected through its gravitational impact on visible matter, as well as through phenomena such as the bending of light in areas of strong gravitational fields, gravitational lensing. The existence of dark matter has been confirmed by observing the motion of galaxies and galaxy clusters, which cannot be explained solely by visible matter. On the other hand, dark energy is a mysterious force that, according to current theories, is responsible for the accelerated expansion of the universe. It makes up about 70% of the total energy in the cosmos, but its origin and properties remain unclear. Recent research and technology have the potential to bring long-awaited answers to the questions of dark matter and dark energy. One of the most promising methods of research is the study of galactic interactions and gravitational anomalies, as well as the search for exotic particles that could constitute dark matter, such as WIMPs, weakly interacting massive particles. In the coming decades, with the development of scientific instruments, we may receive precise data about what this invisible matter is and how it influences the evolution of the universe. What unique technologies might private companies offer for the study of dark matter and energy? Could they become key players in the development of methods to detect dark energy, surpassing traditional space agencies? Despite the significant successes achieved by government space agencies, it is private companies that are beginning to play an increasingly important role in space exploration, including studying enigmatic phenomena like dark matter and dark energy. These companies, with their flexibility, innovative approaches, and ability to quickly implement new technologies, have the potential to significantly accelerate scientific research and provide new tools for observations and experiments. One prominent example of such companies is SpaceX, which, through its Falcon rockets and Dragon spacecraft, has dramatically reduced the cost of launches and increased the accessibility of space research. These achievements create new opportunities for scientific missions, including projects for studying deep space. Other companies, such as Blue Origin, Virgin Galactic, and Rocket Lab, are actively developing their own rockets and technologies for exploring outer space, opening new horizons for astronomers and physicists. Blue Origin is an American private aerospace company founded in 2000 by Jeff Bezos, the founder of Amazon. The company's headquarters are located in Kent, Washington, but most of its testing and rocket launches are conducted on Bezos's ranch in Culberson County, Texas. Blue Origin is actively developing reusable rocket systems and working on projects for suborbital and orbital spaceflights. Virgin Galactic is a company within the Virgin Group, founded by Sir Richard Branson, with the aim of organizing suborbital space tourism flights. In the future, the company plans to expand its services by offering orbital flights. Virgin Galactic is also working on launching small satellites and further developing technologies for space travel, which will make space more accessible to the general public in the future. Rocket Lab is a private aerospace company that started its operations in New Zealand but now has its headquarters in the United States. It specializes in launching small satellites with its lightweight orbital rocket, Electron, and is developing a mid-range rocket, Neutron. The company has also created a suborbital rocket, Atia, making it one of the leading players in the small launch market, offering more affordable solutions for deploying satellites and CubeSats into orbit. Private companies have the ability to develop and launch specialized space telescopes and satellites capable of exploring hard-to-access phenomena like dark matter and energy. They can also play a key role in developing new methods for detecting particles such as WIMPs, and contribute to the development of quantum technologies that will be used to study dark energy. Investments in the space industry from private investors contribute to the development of scientific infrastructure, opening new prospects for collaboration with universities, research institutions, and government agencies. The commercialization of space research will create additional incentives for introducing new ideas and accelerating the pace of scientific discoveries. Drawing inspiration from past discoveries and striving to unlock the most mysterious corners of the universe, humanity stands on the brink of new great achievements. Every step in space exploration, whether it's the discovery of dark matter or new frontiers in studying deep space, reinforces the confidence that incredible breakthroughs lie ahead. Thanks to modern technologies and international collaboration, we are gaining new tools to unravel mysteries that were out of reach just a few decades ago. The path traveled by scientists and space agencies, along with innovative initiatives from private companies, is opening up limitless possibilities for future generations. Join us on this exciting journey of discovery. Subscribe to our channel, stay updated with the latest news, and don't miss the most thrilling events in the world of science and cosmology.